Hey everyone, I'm just going to go over a quick demo today about using SubQuery to index data. This will be quite relevant if you're doing the challenges that rely on any UIs, user interfaces, any other kind of data availability challenges, and there's a few that want you to build a dApp, and this particularly will save you a lot of time and make your life a lot easier. So we'll run through this very simply. SubQuery, this is kind of an agenda, but we'll go through. So the problem we're trying to solve here is querying data on a blockchain. So for those that don't know, the way that data is stored on a blockchain like Cosmos or any of the zones in the interchain isn't really that convenient for querying. It's stored across blocks. You can't query over time ranges, so you can't say, give me all the last 10 transactions related to this account, because the RPCs aren't really set up for those kind of queries. And the RPCs themselves are also very inefficient. So if you're building an application where there's thousands or tens of thousands or hundreds of thousands of users, it's not going to scale. So in order to build these increasingly complex and intuitive applications, developers need more powerful tools to process this data and query it faster. This also is particularly, in Cosmos, this is even a bigger problem. And the reason is, that each zone has its own data set and its own kind of its own database of sorts, each zone its own chain. And as a number of these zones grows, and the whole premise of Cosmos is this interchain communication, this interchain operation, the data from these different zones are all segmented. And they'll require different RPCs, different APIs, and extensive kind of handling to work together. So we need tools that work across all of these zones and combine all that data into one place, ideally for your application, especially if you're building a product that does something over here and then sends something over here and then something comes back later on. So for example, with the neutron challenges that are coming up. So essentially, SubQuery is designed to solve these two main things. We're trying to build a product that's flexible and fast, so you're not wasting weeks building your own indexer. Generally, when we talk to a lot of zones or teams in Cosmos, the number one thing we hear is like, oh, we built our own kind of off-the-shelf indexer to do this, to solve this problem. And so you don't need to do that. We already have one that works for any Cosmos zone, and it will save you a lot more time. And of course, don't worry about incompatibility of different zones, and don't worry about your own production infrastructure. We've got all that sorted for you. So SubQuery is a open source, so free to use, open source. It's a data indexer that is designed to index, transform, and query data to power your applications. It's a custom, the result of it is a custom GraphQL API for your application. And this works seamlessly across any zone, both on the tenement level, on CosmWasm smart contracts, and of course Ethermint as well if you want to do some EVM stuff. It also works, so we look at like a landscape of a dApp that we're building in Cosmos. You have your presentation layer at the top there. You might make a request the chain to save and update data using an RPC interface. That's saved in a WASM kind of virtual machine on the Cosmos chain. You might also include storage from IPFS. You might bring data in from oracles as well. But the piece on the side there is indexer. And the index is not for writing stuff to the chain. It's a layer there to make the retrieval of data faster and to provide a more richer data experience to your application. So the standard way is you write stuff through the RPC directly to the chain, so there's no middleman, but the data indexer provides that read layer back. And if we kind of replace this with things we kind of understand in Cosmos, then you might use BAM protocol for the Oracle and React and Cosmos, but SubQuery is over the side there. So SubQuery, we design it with a few things in mind. We always try to make it as fast as possible. One of the big, the constant thing that always comes up is how fast does it take to index my entire chain? And that depends, obviously, it depends on the density of the events that you want to index. It depends on the block speed of your chain and how long it's been going for. But we're trying to make it faster than others. So compared to like the graph in Ethereum, it's about 2 times faster. And we do a lot of work around caching, pre-computed indexes to make that faster. But it's also very flexible. So one thing that people say to us is, well, why don't I use Covalent to get this data? Covalent provide off-the-shelf APIs, but if you don't want what they're giving you, then it's useless. So SubQuery is really best for, I want specific data for my specific application, for my specific smart contracts. So it's completely flexible, and we'll see how this is done later, but allows you to index data from whatever you want into whatever shape you want. It's open source, free to use. A lot of people have extended it. So we've built a standard indexer, we've built a standard GraphQL API on top of it, but some other people have plumbed it back into some big data BI tools, and they've got their own REST APIs on front of it. You can do whatever you want with SubQuery. And it's universal. So as I mentioned, it works in any Cosmos zone. It works on Tendermint, CosmWasm, Ethermint. But it also works on other chains. So it works on things like Ethereum and all the layer 2s. It works on Polkadot and all the parachains. It works on Algorand. It works on Near. And we're kind of going around and adding support for all these different places. So wherever you want to build and deploy your applications, especially if you're starting to think about cross-chain, which I know us and Cosmos, we're always thinking about cross-chain. We're not really here in Cosmos if we don't believe in multi-chain, cross-chain, all that kind of stuff. So it's a tool that can work in all these places. We do believe we work with any zone. We have tested it with all of these zones, and I've recently tested it with 2 more, Neutron and Archway. But yeah, again, we think it works with anything. We just haven't gone around and built example projects. I know the OKP4 team have actually got it working on their chain, so we need to add you guys up here as well. But yeah, it should work off the shelf, and I'll show you how to make it work. So let's go through and do a quick demo of how to build a SubQuery project. I was hoping to do a live typing thing here, but I've only got one hand. So we're just going to read through some existing code. But it's really simple, and it's not that hard. So when you're building a SubQuery project, there are 3 files we edit, and we'll go through these one by one. I'll jump to the demo now. The way you start, you bring up terminal, you install a CLI tool, and you'll simply type subquery init. I just say Cosmos example. I can then select Cosmos, and we have these boilerplate examples for all of these different chains. I won't continue here, but if you want to get started, let's say on a Neutron project, you can go here, you can click tap on Neutron, and you get a boilerplate with all the RPCs and all the types and the protos, definitions all already added in. So that's the easiest way to get started. We'll add more chains as we go through. But what this kind of looks like, and I won't initialize this project here, is the code looks like this. And let's view this in. I'm going to show a couple of projects today. And these are various examples from different networks that we'll run through to kind of show you how SubQuery project works. So the first one I'm going to show you is one from Say network. Say is building like a DEX kind of optimize zone, and they have a lot of price feeds that are constantly coming through and prices that have been saved on chain. And this project is for a DEX called Lavana, which operates on Say and a few other chains, I believe, as well, that were built with them, just to very simply index price feeds. So there are 3 files when editing a SubQuery project. The first one is the GraphQL Schema. And I always start with this one because it defines the shape of the resulting data that we want. So remember, a SubQuery project, it takes data from the chain, it processes it, and it saves it into a database, so then you can query from. And this GraphQL Schema really defines the shape of that resulting data. So it's in GraphQL. Imagine there's 2 entities here. There's an exchange rate entity, and there's a daily aggregation entity. These map towards database tables. And you will have, for example, in the exchange rate table, we have an ID column, a block height column, a timestamp, transaction hash, contract address, and so forth. So you're just defining the types, the tables, the shape of the resulting data. So I want to index. Obviously, you can see here that this project is indexing every single exchange rate that is being kind of submitted to the chain, and it's also aggregating that to a daily aggregation. So you can have a graph in your UI of the open, close, high, low prices of those rates over time on each daily basis. Okay? You can have foreign keys in these entities, and we'll kind of go into that one a bit later soon. So this is a Graphql schema. This is the end result of my data. The second file that we edit is the manifest. And this is really the only thing that's different across different chains. This is the where and the what am I indexing. So in this case, we're indexing from Say Network. Their chain ID is called Atlantic 2. We have copied across these RPC endpoints. Now, SubQuery just needs access to an RPC endpoint. Ideally, it's an archive. It has the full history state, because if you want to index the entire history, you need obviously be able to connect to an RPC that has the history. A lot of Cosmos chains don't have great availability of archives. But if you're indexing a new smart contract, the node just has to have the state from when you deployed that contract. And you can have multiple for performance reasons, but also reliability reasons. We also have a dictionary. Some chains will provide this. A dictionary is a pre-computed index of every single event and transaction on chain, and it just speeds up the indexing process, because rather than having to peek into each block to see if there's a relevant event, we can kind of skip through it. And then in Cosmos, the one kind of developer, it's a bit of a tricky developer thing for Cosmos, is we actually have to manually import the protobuf definitions of what we want. So the CosmJS will decode or try to decode that transaction or event or message, and we need to have the proto files to be able to decode that. There's no easy way to automatically import them, we found. I was talking to a bunch of guys outside about a better way we can do this, but essentially, to make it work on a chain, go to their repo, download their proto definitions, and whatever you want to index, you might have to download and link the proto definitions. So in this case, I'm indexing messages that are sent to update the exchange rates on Say, and so there's a message send proto definition in this file that I have in this directory here, which I just got from Say's GitHub. Okay. This is where it gets a bit more interesting. So this is where we define the trigger points. Think of them as trigger points on the chain. In this case, there are two that we're indexing. Say Network, they put a event, they put, in this one here, this is an event. They put an event on chain every time there's a funding rate change. And I can go over here and show you what that looks like in an Explorer. This is a particular transaction that's come through on this block height. It was last month. And it's defined here, let me make this bigger, that they log that the funding rate was changed. And you can just see that in, I think it's in this events array here. No, it's another one. Yeah, there's something down here, sorry. Yeah, there's an event here, a type that if I can find it, I'd love to find it somewhere down here. It's one of these arrays of events that we're looking for. But it's how they define, it's how they log that a funding rate has changed. And essentially what a SubQuery project is going is it's looking through and scanning the blockchain for this particular event. For this funding rate change event. So we set these different filter criteria, and you can have different filters on names or on contracts or on addresses. And then as soon as the SubQuery project hits that thing, it processes that. So we're looking for anything of type WASM funding rate change on the message execute contract, and then we'll run a mapping function called handle funding rate change event. Similarly, we can also do, there's another one called a spot price. So whenever a spot price is set, there is another event that is logged with that name, and we run the function there. And then this is in our mapping file. The third and final file is basically we define a TypeScript process to handle these. So handle funding rate change event receives a Cosmos event, and the way that data is stored on an event is it's stored in a key value array. I'm seeing if I can find this, to be honest. It's a lot easier when you can kind of show it. Yeah, here we go. So it's a WASM funding rate change, and the way that this is stored is it's stored, or the payload of the data is a key value array of the contract address, the time of that funding rate, the long rate, the short rate, and the particular contract type. And that's stored on chain. We basically pull that out. We process that event by first logging that we have it. We confirm that the contract address is correct. We then retrieve an existing exchange rate if we have one, and we update that. And we pull off the pieces from the keys, the time, the long rate, the short rate, the contract version, the contract name, and we save that. And we save that to the store, and that saves the database. We also then update the daily aggregation, which is through this function here, which will, from that day, we feed it the price that we got, and it updates the daily aggregation by first retrieving. So we get like an ISO string of like 2023-06-23, and retrieve that. If it doesn't exist, we create a new one, and then we update the high, low, and the close price of that. So essentially, we always keep updating these things as we go through. Now you can run this. This is all very simple TypeScript code. One of the big differences between us and the graph, and if you've used the graph before, this is very familiar. So it's the same three file structures of the Graphql Schema, the manifest, and the mapping functions. The main difference between us and the graph is that the graph's an assembly script, so you're limited in terms of what you can do here. We are in TypeScript. You can do whatever you want. You can be deterministic like we are in this case, but you could also import existing other libraries. You can make an RPC call to get some additional data from the chain. You could request some data from IPFS. You could make an API called CoinGecko to get a USD price from there. You can do whatever you want. So you're not limited to be deterministic in this sense. So this is the end result of running this is that you can run this in Docker with one command. It will spin up an indexer. That indexer will also spin up a Postgres database. That indexer will run. It will connect to the chain. It will start at the start block defined. It will look through the chain for any events that match the filter criteria. It will process it according to the mapping functions you define here, and it will save it into that database using those store methods. And then it will also spin up a GraphQL endpoint that you can then query with. Okay? So after run this in Docker, you get this basically this process that will scan the whole chain, process that data, store in a database, and give you an API for it. This isn't a particular example for, say, if we went to something else like Osmosis. Osmosis, obviously everyone knows, we've built a project for them that, if we look at the same thing, it indexes every single swap made on Osmosis and the route that swap took. So a swap, there's three entities, a swap, and then each swap has one or more swap routes, different steps it went through different pools that swap went through. So there's three fields here, or three entities with foreign keys between. There's relationships between all three of these. And in GraphQL, you can kind of navigate through those and filter on those foreign keys. The manifest for Osmosis for this project here, it looks like this. It literally looks for any message of the message swap exact amount in. If you know anything about Osmosis, there's also like a message swap exact amount out, but it'll be the same process. It's just you have different restrictions on what you're swapping in and out. And then anytime it finds a message on the chain that matches this filter criteria, it runs this mapping file, which receives a Cosmos message. We type it out to make things a bit easier, and it creates a swap. It then saves that. So basically, we can, by providing a type here, we can, the typing is just a lot easier. This is from Osmo.js. And so we can, after decoding, we know it's sender, token in, denom, and out amount. And then we saved it, and then we also, the swap routes in this message are an array of routes. And we can check that the pool exists, that the route is going through. If it doesn't, we create a new one, and then we create a swap route record. And the same process, you run this, it spins up a Docker, like a Docker container with an indexer, a Postgres database, a query service, and it will index every single swap ever made for the message exact, like in swap kind of style. And provide that data set to you for you to use in whatever way you want. So very simple example of how you can use SubQuery to index any data. And you'll notice that, yeah, there's anything you do here. There's a whole bunch of example projects through here for all these different networks. One thing I also want to show you is we support this concept of multi-chain indexing. But before I get dumped there, I'll just mention the different other examples. One of the hardest things that people get caught up on is how you define the filter criteria for when you want to run something. So this is, for example, a Juno contract, and we can filter on contract address and the attributes. We can filter on the message type. We can filter on the message handlers a contract call, the exact contract call you're calling. So there's a lot of different filter criteria you can do. You can include failed transactions, for example. By default, we don't, but you can override it to include failed transactions as well. So the whole heap of documentation that we'll share after this as well. One of the big things I want to talk about, though, is multi-chain support. I don't have a great Cosmos example I can show you here, but it's very straightforward. Essentially, it allows you to index data from 2 different zones or 2 different tile layer ones into one data set. So as long as the schema, the database schema, the GraphQL schema is the same, you can run 2 different indexes across 2 different chains simultaneously. You obviously have to sort out concurrency issues and IDs, but you can index that data into one place. So for example, if you're indexing a bridge or a cross zone, I know, for example, the Neutron challenge is about interchain queries. You could, or interchain execution of contracts. You can index on both sides into one data set. And the way you do that is there's some documentation here around some commands, but you basically have multiple manifests, and each manifest includes the chain IDs and the particular events on chain you want to index. But then you can feed that into the same mapping functions, and it has to go into the same database schema. So there's a whole bit of documentation on that, but that's particularly relevant for Cosmos, but also particularly relevant for this hackathon coming up. In terms of running this, so you're building this away, it runs in Docker locally on your computer, it's very lightweight. We've tested this, actually runs on a Raspberry Pi, because it just deals with an RPC and saves into a database. But we do, in terms of longer term running it, let's just go back into our slides. Before we kind of carry on, I'll just say what we've seen. We've seen indexing simple set of events, running the project using Docker containers, one command. I didn't quite do that because it's too hard with one hand. How to write more complex mapping functions, and how easy it could be added to multi-chain support for many more zones. One things we try to do here is, I've already kind of covered a lot of this stuff. It's all lightweight. It's all GraphQL, fast re-indexing. Let me just actually run one of these, because why not? I'll run one for Archway. Oh, no, I can do it, say. Just in the background, dev, and I'll come back to this soon when it's running. So yarn dev is just a command. It just builds the types. So it code gens the types. It builds the project. It starts up a Postgres database, as you can see here, and then starts up a node that will then sync. So it registers some chain messages. I'll just make this a bit smaller so you can see, and starts securing blocks. One of these RPCs doesn't actually have the block height, the history, so I might have to remove that, or we might try a different endpoint. And this is one of the big issues we have with Cosmos, is a lot of the RPCs, they're all very free, but they don't really keep that much of a historic state, unfortunately. But what I can do is I can just update the lowest height to be something more recent for now. I'll just clear out the database. All right, database is ready. It's now sign up node. it's starting to make queries to osmosis endpoint. The endpoint might be getting rate limited. Yeah, we're getting rate limited on the endpoint, but it should work in the background. But anyway, I'll come back to this. In terms of, you can run this yourself locally. We provide a lot of open source kind of information about how to run stuff, but we also provide a managed service. So if you are building a production project and you don't want to worry about the production infrastructure, because nobody wants to worry about production infrastructure. It's the most horrible thing to do in the world. No one wants to be woken up at 2 a.m. when something inevitably breaks. It always happens. We do provide a managed service where you can deploy your project to. You get 2 free projects, and some of our larger customers, for example, one of the biggest wallet in Polkadot uses us, and they run a project for every one of the 70 different parachains in Polkadot in our managed service. So, we do a lot of work around reliability there. There's like 99.9% uptime guarantees for them. So when shit breaks, we're the ones that wake up at 3 in the morning. And that serves hundreds of millions of requests per day. But that's there for you if you want to scale this up to a production application. We're also working on a decentralized network. That's the view there. I can actually quickly jump over to the Explorer and kind of quick look for it. So like here's some projects, for example, that are using this. A lot of them for other ecosystems. White Whale, for example, is a DeFi platform on Juno, and they use this quite a bit for their DEX. Their front end, I believe, actually runs on this. So if you go inspect the network packets for their DEX, you probably see them making requests to our hosted service, and I think they index pretty much everything, including prices, I guess. I haven't actually run through their project recently. Let's see what they have here. First 10 prices, ID, and prices. Yeah, I guess the indexing price data from all these different things, and we can probably sort this by, Graphql is pretty cool about this. Like you can say, like, give me the highest order by date time descending. So the most recent prices for AXL USDC is 1, is Juno is that, Atom is that. So yeah, this is kind of example of a real world kind of production SubQuery project being used by a production DeFi app on Juno and relying on that in their front end. So this is GraphQL. It's kind of neat. It's like SQL but safe to do the internet. You can kind of this query is the same as like select limit 10 ID comma prices from prices order by date time descending. It's kind of neat. As that's a managed service, and you can deploy to that. It's all self-service. We're also building a decentralized network, and the plan is that anyone building a project can one of the final centralized pieces of a dApp. The network's decentralized. RPCs are kind of still centralized, I guess, but indexes are on the last other like centralized services. Someone's running that database somewhere, whether it's our hosted service or you guys are running it on your own infrastructure. So if we want to be able to say hand on heart to everyone that this is a completely decentralized and unstoppable app that is deployed in IPFS and decentralized every other way, index is one of the last ones, so that's what we're working on here. And essentially, you build that project that I just showed you, you go to the world and say, can someone please index this? And a random person around the world can index that data, multiple people can, and the network will handle the load balancing, the verification that the data they have is correct, and the rewards of those indexes to pay for their infrastructure costs. So you can easily plumb this into your app, that your app makes a request and the network kind of loads that out to the nearest indexer to your user, and those indexes are rewarded based on the requests that they make and the stake that they have. So we've just launched a pre-mainnet version of this. We're just testing it slowly, making sure that the indexes are kind of reliable because our customers mostly care about uptime. So we're just taking our time to make it slowly get working and making sure the reward rates are correct. So indexes aren't running infrastructure and not making enough to cover it. And then, so that's the network there. We've even got like a example We've even like started onboarding some projects. So there's actually, you can kind of see the Explorer right now. We've only got a few projects running on it. For example, this app uses that same architecture that I mentioned in this slide here. And this is one of my favorite things to look at, is the app that runs like a network explorer or a network kind of admin app is the same architecture. And we use a SubQuery project, which we use 3 SubQuery projects actually, one for the main application, one for the airdrop, and one for the exchange or swap mechanism, to power this website. So this website is making requests to our decentralized network using a SubQuery project that's running on that decentralized network to provide the data for this. And we save data to the chain through an RPC, but the data being shown here, including the list of indexes and their scores and like the scores, the indexes, the historic uptime, the rewards that they've received, all of this information comes from a SubQuery project running on the SubQuery network. So it's a perfect example of us eating our own dog food, eating our own food to make this work. So yeah, that's SubQuery in a nutshell. That should be how you can use it to build an app. And it should be pretty straightforward to use. If you have any questions, that's my Telegram details. And feel free to start trying it out. Yeah. Quick.